In the previous video, we discussed how 3D printing works and the advantages and limitations of using additive manufacturing as opposed to traditional manufacturing. In order to really understand all the possibilities that 3D printing has to offer, we will now discuss 5 categories of 3D printing: fused deposition modeling, stereolithography, powder bed fusion, binder jetting, and material jetting. Fused deposition modeling, or FDM, is a process in which material is selectively deposited through a nozzle. First, a spool of thermoplastic filament is fed into a hot end, also called an extruder. This hot end heats the filament into a liquid state, and then uses a gantry system to move the hot end along the X, Y, and Z axes. The nozzle deposits the liquid material layer by layer until the part is complete. Finally, any support material can be removed and you are left with your final part. Materials available for FDM printers include an incredibly wide range of thermoplastics. Standard plastics like PLA, which is a biodegradable plastic made from cornstarch, is one of the most popular and least expensive choices of material. ABS is another popular material, and is actually the same material that Lego blocks are made from. These types of plastics are used for non-critical applications. Engineering plastics like nylon and TPU are often used for structural applications, and advanced plastics like Ultem and PEEK are used for mechanical, thermal, or high-strength applications. The wide range of thermoplastic availability is one advantage of using the FDM process. Additionally, it creates little wasted material. In fact, thermoplastics are recyclable, so failed prints and removed support structures can be recycled into new filament and used again. FDM systems and materials are pretty low cost. The size of FDM printers is also extremely scalable. Large systems can be used to quickly print concrete or adobe homes at incredibly low costs. On the other hand, FDM prints are less accurate and have lower resolution than parts printed by other methods. They have a poor surface finish, and the layers are visible to the naked eye, unlike the high-resolution parts printed by the SLA method. FDM prints are porous. A drinking glass printed with food-safe material could still retain liquids and harbor bacteria in between its layers. With the exception of some advanced plastics, most FDM materials can only be used in low-heat applications, since they are thermoplastics and have far lower melting points than other materials. The next method of 3D printing is stereolithography, or SLA. This is a process in which liquid photopolymer, or resin, in a tank is selectively cured by ultraviolet light. First, liquid resin is poured into a tank. A UV light draws the first layer of the print onto a platform by selectively curing the resin. The platform is raised after each layer is cured until the entire part is complete. The part is then removed from the machine. Next, the part gets washed in isopropyl alcohol and then is placed into a UV oven to fully cure. The materials available to use in the SLA process include polymer resins and composite resins. The SLA process prints parts with high resolution and high dimensional accuracy because the diameter of the UV laser is so small and precise. This results in parts with excellent surface finish. Additionally, there are many SLA materials that are translucent or transparent. Any leftover uncured liquid resin can be reused, so little material gets wasted. However, cured resins are not at all biodegradable or recyclable. While there are many resins available, the SLA materials are still limited to only photocurable resins, which can be messy to work with and can produce dangerous fumes if not in a well-ventilated area. Of course, post-processing is absolutely required for SLA prints, though these parts will still always remain light-sensitive and should not be exposed to direct sunlight for long periods of time. Powder bed fusion is a process in which thermal energy, like a laser beam, selectively fuses powder material. First, a thin layer of powder material is evenly rolled onto a platform that sits in a bed of powder. The laser beam draws on the platform, selectively fusing the powder material together. The platform lowers and the laser fuses another layer of material. This process repeats until the part is complete. The parts will always have to undergo post-processing like powder removal, but they will also often have to go through other lengthy post-processing techniques in order to improve the mechanical properties of the part. The materials available to use in the powder bed fusion process include metals like steel, iron, titanium, and nickel alloys, as well as some polymers, typically nylon reinforced with glass or aluminum. One big advantage of powder bed fusion is the availability of powdered metals. This process can actually produce parts made of superalloys, metal alloys with superior mechanical properties that cannot easily be manufactured by traditional methods. Minimum support structure is needed because the unfused powder acts as support to the part. Additionally, unfused powder can be recycled and used again. Some disadvantages of powder bed fusion include slow, long print times, as well as lengthy post-processing techniques. Also, powdered materials are expensive and can be dangerous to work with, so they do require special safety measures and PPE. Binder jetting is a process in which a liquid binding agent is selectively deposited to join powdered materials. First, a thin layer of powder material is evenly rolled onto a platform that sits in a bed of powder. A print head, similar to one used by inkjet printers, selectively deposits the binding agent, which essentially glues the powdered material together. The platform lowers and the process repeats until the part is complete. The excess powder is removed, and we are left with a part that takes the form of the final shape, but is not yet fully bonded together. The part must undergo a heat treatment, and usually other forms of post-processing, to produce a functional part. Binder jetting materials include polymers, metals, sands, and ceramics. Unlike the previous methods of 3D printing, binder jetting allows us to print full colored parts because the binding agent and color can be applied at the same time by the print head. Virtually any material that comes in powder form can be printed in the binder jetting process, and there are many binder powder combinations available. This process is also less expensive and much faster than powder bed fusion. Unfortunately, binder jet parts have low structural integrity, and parts that are bonded but not yet heat treated can be very difficult to handle. Post-processing is required, and parts are prone to shrinkage at this time. The amount of shrinkage is easier to predict for smaller parts, but it is a challenge for bigger parts, making dimensional accuracy a little harder to achieve. Material jetting is a process in which droplets of build material, specifically photopolymers, are selectively deposited. First, a print head, similar to one used by inkjet printers, selectively deposits tiny droplets of the build material onto a platform. A UV light that is also located on the print head immediately cures the material. More layers of material are deposited and cured on top of each other until the part is complete. Finally, any support material can be removed. Materials used in this process are limited to photopolymers and wax, which is a popular material choice for jewelry mold making. Like binder jetting, material jetting allows us to print in full color, and this process allows us to print multiple materials in one build. The process is fast and produces dimensionally accurate parts. On the other hand, this process limits us to only liquid materials. It produces low-strength parts and more wasted material than other methods because it requires more supports, which are cured by UV light and therefore unable to be recycled or reused. Material jetting is also one of the most expensive 3D printing processes, as the machines and the materials are pretty pricey.